Hi. Let's say you design something in Blender that consists of many pieces and you need to emboss a number. For example, you want to 3D print all these pieces and you need to know the numbers so that you can place them. For example, what I did here, maybe you saw the video on the channel. It is this 3D printed sound diffuser panel that you can see up there. And when I made a prototype, I printed each spike individually. And so I had to emboss a number. Maybe you can see it here. Each piece has a number, so that when I glued them to the canvas, so these are 100 individually printed pieces, each of these pieces has a number embossed on the back, so that when I put it all together, I knew I have to stick number 0 here, 1, 2, 3, 4, and so on. Okay, so how do you emboss a bunch of numbers into a bunch of objects in Blender? That's what we're gonna do in this hopefully quick tutorial. Like and subscribe below. Let's do this. Alright, so at some point in the tutorial we got to this point where we have all of these spikes. This is one object, and in this case I didn't want to print individual spikes like what I've shown you before, this kind of thing. I wanted to cut this into chunks where each chunk fits onto my printer's print bed. So I decided to cut it into 12 chunks like this. Now, I wouldn't really need numbers for this because I could sort of figure out which part goes where if I want to glue this onto a board or canvas. Anyway, it doesn't matter if you need 12 numbers or 200 numbers. Same method that I'm going to show you right now. So I'm gonna add a new object, and that is just so that I can create a new node tree, because down here I'm inside of geometry nodes. I'm gonna call this numbers, and this node tree I'm gonna call numbers. And I just do that so that I have a separate object that I can figure out how and where to put these numbers. And then I can use this node tree at the end on my actual grid object to cut the numbers into this object. Okay, so how do you create a single number in geometry nodes? Well, there is a string to curve node. String to curves. So if I plug that in here and I put a string in here, let's say number 42, I get the number 42. And this is just the outline, it's just a curve. Okay? Of course, this is huge, so I can change the size here. And also, in order to use this for a Boolean modifier, I need an actual three-dimensional object. So these are just the outlines. What do I have to do to make this into a three-dimensional object? First, I'm gonna have to fill the curve. Fill curve. Done. Okay. Now I need to extrude it. Or actually a solidify modifier would be nice, but there is no such thing in solidify in geometry nodes. There is an extrude mesh node, however. And as you can see, it extrudes the number 42. Of course, this is huge. So let's bring this down to something smaller. The extrude mesh node is not like a solidify modifier. It moves the number that was originally down here, up here, and it creates the side walls. However, it doesn't create a bottom. And also our fill curve created triangles. It creates all of this stuff. That's easy to fix. We just switch off individual. So now we have the outer shell, the top, but no bottom. And I wish the extrude mesh node has sort of a checkbox that says act as a solidify modifier, but it doesn't. Maybe this is coming. I don't know. But we can sort of fix this, right? So this is what we have. And we know that this curve is the number 42 down here. So all we really need to do is join the geometry, this one and that one. And now we have a bottom, we have the top, we have the sides, all good. However, if I switch on face orientation, this looks good, but the bottom, of course, now faces the wrong direction. That's not good. So this part here is in the wrong direction. We can flip that easily around like that, and now our number 42 is all blue, which is what we need. Okay, anyway, we're still not done because the extruded stuff and our original number down here are still two separate things. They're in the same place, but they're not actually connected. They're still separate things. How can we connect this bottom piece to our extruded number? We have to merge by distance. It kind of sucks, and maybe there's a better way, but this is the way I know how to do it. So really all of this is just an extrude or a solidify. Necessary to solidify the number with the normals pointing in the right direction. And now we have a single number. Cool. Cool. So, next, we need to create 12 numbers. And we need to place those numbers so that we can actually Boolean cut them into our object. So we need 12 numbers and we need them on a grid. So naturally we're gonna go search for grid. That gives us a mesh grid. We need 4 on the X and 3 on the Y, right? 4 by 3. This is what I've drawn here. And that gives us a mesh. So let me plug that in here. Looks like this, and it has the subdivisions. So how big does this mesh need to be? Let's think about the numbers real quick. If we want to cut into these objects here, really we can only cut into the spike because that has volume. So really I think I want to place a number on one of the spikes here and then cut in there. So first of all, I need tinier, smaller numbers. And then I need the grid to go from here and then a division here, vertex here, and then, hold on, and then another one here. So actually I know that one spike is 40 millimeters, so I need 40 times 12. 40 times 12. 40 millimeters times 12. That should be the size on the X. And then on the Y, same thing, but in this case, I need 40 millimeters times 8. So this mesh should now be this size. Okay, now we have to move this grid. So this is always a transform geometry because we can move over now and up a little. Okay, this looks perfect. So this grid has a 4 by 3 division. So we actually get these vertices here, and then we get another one here and another one here. And then of course also this one here and so on and so forth. Cool. So this is where we need to place our numbers. And we need 12 numbers now. So if you want to repeat something in geometry nodes, you need a repeat zone. With a repeat zone, anything that's inside the zone gets repeated this many times. And I just said we need 12, so I can put in 12. Or let's say I need more than 12. Let's say I need 100 or whatever, or it depends on this grid. I can make this dependent on this grid by using a domain size node. I use my grid. I count the point, which in this case is 12. And so this is another way to sort of make this more parametric. Okay, so now this gets repeated 12 times. So if I plug this in here and I go, okay, I start with an empty geometry. That's cool. And then I create a number. And back here, I join my number to my empty geometry. Now, actually, what I get here is, if I plug that in here, I get 12 numbers joined. So this output here is now the 12 numbers. However, they're still all in the same location. That's not good. Let's put them all into different locations. And also I'm going to bring down the size to something like this. So how do we get the locations, which is what this grid is for? Well, we need to sample the index of the vertex of my grid, and I need an iterator. My repeat zone gets repeated 12 times, but I don't have an iterator yet. I can go to this node, to the node, create a new thingy here, I, and it's not geometry, it is integer, and I called it I, okay, as an iterator. And if I plug that in here now, it's not doing anything. We start with 0 and we just repeat 0 all the time. But of course, if we add a math node and add 1 on each iteration, we now have an iterator. Starts at 0 and counts up to 11. Now we need the position from this grid, actually from the transformed grid. So from this output here. So we need to sample index. We need to sample this geometry, the grid, at an index. The index is our iterator. And what do we want? We want a vector from the point, yeah, from the vertex of the grid. And we want the position value. And this is where this number should actually go. So let's transform this number to this position. Cool, now we have a bunch of 42s, but they're in the right position. I can switch this to be center and middle. And then I bring down the size even more. What is a good size? This probably. So this will be a cool number to punch into the bottom of our object. Now, of course, we don't want all 42s. We actually want to use our index here. And we can plug a string in here. There's a value to string node. As you can see, we use our index as the value, convert it to a string, use that to create the number. And now we have 0, 1, 2, 3, 4, 5, and that is just the order that the grid node creates the vertices of the grid. This grid is just to get the positions. That's all we need that for. Down here, we create a single number. With the loop, we create the correct amount of numbers. And then that's the output here. Now those are a bit tall. And that is because the extrude is still very tall. And they're all sticking inside, but they're on the same level. Nothing is sticking out on the bottom. I know that this is a problem for the Boolean modifier. So what I'm going to do back here at the end of the repeat zone, that's the 12 numbers. I'm going to again transform the geometry and move that down on the C and just stick it in there just a little bit. Maybe 3. Oh, okay. So 2, 5. Okay. So now they're just sticking in there a little bit. And now I can use this for a Boolean modifier. All right, now let's go back to this object. Let me disable this. And on this object now, I'm going to hide the numbers because I'm going to use, let me save this quick, because I'm going to use the geometry node tree. So on this object, I'm going to add a geometry node and use my numbers node tree that I just created. Okay. Now this group input is actually the spikes and these are the numbers. So what I need to do here is I need to mesh Boolean. I want to use the spikes and I want to cut away, which is difference, the numbers. So I'm cutting the numbers into this big object here. And if I switch on timing here, you can see that the Boolean operations are very slow. So this node alone takes more than 2 seconds. And what is the output? We can see we get something, but some numbers are missing, which kind of sucks. And also they're mirrored. Well, we can take care of the mirroring quite easily. So these are our numbers. The transform here, we moved them up on the C-axis a little bit so that we're actually cutting into the object. We can use that same transform node to scale on the X -1, and that should mirror the entire object over. And so we're looking at it from the bottom. We actually can read the number. but there's some numbers missing here. Now there's a few tricks here. The first thing you can try is you can increase the amount of geometry you have both on the numbers and on the object that you're cutting into. Another trick is to try out if the exact mode for the mesh boolean fixes things. So let's switch it over to exact and see what happens. It's taking some time. And actually this looks good, but it cut away parts here. So let me go back to float, because we're missing this part now. See? So this is not it. Let me think about this quick here. We get instances. Oh, so we could try and realize the instances of the numbers. What does that do? First of all, it speeds this up quite a bit, doesn't it? Realize instances, but it's still the same. And then we get red numbers, which means that the normals are flipped. Okay, so what about if we flip after we realize we flip, then we get this. Okay, still not all of the numbers. If you've ever used the Boolean modifier, you know that shifting things around just ever so slightly can change the result. So let's try that. Let's move this, just add a little something there. Where the grid is, yeah. Okay, that looks cool. So we have all the numbers. We actually have the bottoms in there, because sometimes the Boolean just cuts holes and then we don't have watertight mesh and then the slicer isn't happy. So this actually looks pretty good now. Okay. Yeah, yep. So we have numbers embossed into the bottom. We can read the number from the bottom. And if we cut this, or if we apply this modifier now, we actually have the numbers in there. And then we can cut this into the pieces that we wanted to cut. Yep. So that's it. Now, quick recap of what we did in Geometry Nodes. So we create a grid and we transform the grid. This is just to get the positions where we want to place our numbers. Inside of a repeat zone, which goes from here to all the way over here, we create a number. And we use our iterator here, which is just an integer counting up from 0, adding 1 on each iteration. So we get 0, 1, 2, 3, 4, 5, and so on. We use that, convert that to a string, create a curve, fill that curve, and then extrude and join with the flipped faces. This is sort of our solidify. We merge by distance. It's also still part of the solidify. So we get three-dimensional number. Okay, so the output here of this is a three-dimensional number. We transform that number and we place it where? In a new location, the location of the vertex of the transformed grid here, at a certain index. That's the index of the iterator. And this is the position of the vertex. Okay, so this is where our number goes. And we do that 12 times in this case. And we join each number that we generate to the geometry that we get from our iteration. So we are starting with an empty geometry here. And these are just, we put the numbers all into this geometry. So the output here is the 12 three-dimensional numbers. Then we move those numbers up or down a little bit to make it stick into the actual object that we want to cut into. And we also use this transform to flip everything on the x by scaling it -1 on the x. So we can actually read the number from the bottom, not the top. Then these are instances, we realize the instances and we flip the faces. This is just a little bit of thing you have to figure out so that the mesh Boolean modifier actually works. Okay, and then we use our sound diffuser object, which is this input, and we cut away the numbers, and that's it. And the little tricky part to make the numbers actually cut out with the Boolean modifier is to nudge around the grid a little bit. And yeah, this is a little bit of trial and error, but I think we did it. We now have the geometry here. We have the numbers in there. We can now apply this geometry nodes modifier so that the numbers are actually in the geometry. And then we can cut this into the pieces. And I've already shown how to do that in the other tutorial. So that's it for this one. I hope you learned something new. I do recommend checking out the other tutorial where we actually created this, this geometry and all the spikes and how we moved it around with proportional editing. And then there's another video where I actually 3D printed all of this, and then I created this wall art that you can see there. And that's over on my other channel, Crispy Tech. So please like this video, like all the other videos, subscribe to both channels. Thanks for watching. See you in the next one.